Hi, welcome to my video on extra problems. This is extra problems pertaining to the polynomial function. And if you wish, you can pause your video and work each of these out before I do. Number 1. Negative 2 is the root of this equation. X cubed plus 4x squared minus kx plus 18 equals 0. Find the value of k and find the other roots. Okay, so if we sub negative 2 in the place of x, which is what I'm going to do here, when I sub negative 2 in the place of x, that will give me a remainder of 0. So that makes this equal to 0. So negative 2 is a root, subbing it in will give me a 0. 0 remainder equal to 0. So I'll work that out. I get a negative 8. Negative 2 squared is 4, so that gives me 16. That's a plus 2k plus 18 equals 0. And negative 8, add on 16 is 8. 8 and 28 is a plus 26 equals 0. 2k is negative 26. Divide by negative 2. K is negative 13. So if k is negative 13, we can sub x cubed plus 4x squared. K is negative 13, so it's a negative of a negative 13x plus 18 equals 0. So x cubed plus 4x squared plus 13x plus 18 equals 0. And it says negative 2 is a root. So let's put, we know negative 2 is a root. So let's do synthetic division on the negative 2. 1, 4, 13, 18. When I do, I should get a remainder of 0 here. And that will give me a quadratic left. So bring down to 1, multiply, negative 2, add 2. Multiply, negative 4, add 9. Multiply, negative 18, add 0. So we knew negative 2 was a root because we said it from the beginning. But we just checked. We got 0. Now we have the quadratic equation, which is x squared plus 2x plus 9 equals 0. So this is x cubed, x squared, x constant. So this is the remainder. So that's constant, linear, quadratic. So A, B, and C. We can't, factors of 9 can't give us a 2. So they could be real roots, but factors of 9 that we know of as integral roots are 1, 9, and 3. So plus minus 1, plus minus 3, plus minus 9 won't give you a 2. So we have to use the quadratic formula. X equals negative b plus or minus square root b squared minus 4ac all over 2a. So that's b is 2, so it's negative 2 plus or minus the square root of 2 squared minus 4. A is 1. C is 9 all over 2 times 1. So that gives us a negative 2 plus or minus. And I'm working all this out here on the side. 2 squared is a 4. That's negative 4 times 9 is negative 36. That's a negative 32. And that's a negative 16 times 2. So it's a 4. Because it's negative, I have an I root 2. So that's a 4I root 2 divided by 2. So negative 2 divided by 2 is negative 1. 4 divided by 2 is 2. So it's plus minus I root 2. So the other roots are negative 1 plus 2I root 2. Or negative 1 minus 2I root 2, or the other. So we found the value of k to be negative 13, subbed it in the equation, and did synthetic division to get the pressed equation to come up with these two roots. Number 2, 4 plus 2y is the zero of this polynomial, x squared minus 6x plus k. A zero means that the x, or the zero, or the root, so if we sub the 4 plus root 2 in for x, 4 plus root 2 subbed in for x, so the 0 subbed in gives me a remainder of 0. So again, a 0 is the root, is an intercept of a graph, so when we sub that in, we get a remainder of 0. So we're going to square this now. 4 times 4 is 16. Multiply this. That's a 4 root 2, and double it is 8 root 2. Square root 2 times root 2 is root 4, which is 2. Negative 6 times 4 is negative 24. Negative 6 times root 2 is negative 6 root 2 plus 2k. And we simplify all that. Let's see what we have here. We have a 8 and a negative 24 and a 4, so that's 20, so that gives us negative 4. And that's 8 root 2, negative 6 root 2 is positive 2 root 2 plus 2k. So we're trying to find what k is, so 2k is equal to 4 minus 2 root 2. And we divide by 2 on each side. So k is 4 divided by 2 is 2, and 2 root 2 divided by 2 is negative root 2. So notice right here, 4 over 2 minus 2 root 2 over 2. So 2 divides into both of these. You don't divide 2 into 4 and leave it alone. 2 has to go into both of these. So 4 divided by 2 is 2. And we had this, did I add this up correctly? 20, 24. Oh, root 2 squared. I put a 4 there. I said, again, notice, I said what? Root 2 times root 2 is root 4, which is 2, but I put a 4 down. So that ends up to be 18, so that ends up to be a 6. So that ends up to be negative 6, so that's a 6. So that's a 3, and that's a 6. So that's a 3. Sorry about that. What I said and what I put down was two different things. I do make those mental errors. Okay, let's go on and do a few more. Another question I've often seen around pertaining to the cubics and the quartics. Explain why this equation, which is a cubic equation, descending order, has an irrational root between 2 and 3. It has that irrational. Notice it's a cubic. So a cubic has 3 roots. And every odd equation, so 3 roots is odd. So therefore, because it's odd, it has at least one real root. Remember, if they're imaginary roots, they come in pairs. So imaginary roots could be degree 2, quadratic, degree 4, quartics, degree 6, if you want. But because it's cubic, it has at least one real root. So notice that this is a 1 and this is 5. So P is 5 and Q is 1. So the possible rational roots are the factors of 5 divided by 1. So the possible rational roots are plus minus 1 and 5. So if we check the 1 and the 5, let's see, let's do 1 possible rational. That's a P here, poor spelling. I'm going to check to see if 1 is the only rational roots we can have is plus minus 1 plus minus 5. Let's do synthetic division on 1, negative 3, negative 1, and 5. Draw a line, bring down your 1, multiply 1. Negative 2 when you add, multiply. Negative 2 add negative 3. 1 times negative 3 is negative 3, 2. Notice the remainder is 2. 1 is not a root. So let's check to see if negative 1 is a root. Remember, the only rational roots you could have are the factors of 5, which is plus minus 1 plus. So I'm checking each one of them. 1, multiply, negative 1, add, negative 4, multiply, 4, add, 3, multiply, negative 3, add, 2. Again, negative 1 is not a root. So now we check that, we check 1, negative 1. Let's check the 5. So we got 1, negative 3, negative 1, 5. Bring down your 1, multiply, 5, add to get 2, multiply, 10, add to get 9, multiply, you get 45, add, you get 50. Nope, remainder is 50. Now I'm going to do negative 5. So I'm checking each one. Notice I'm doing each one at a time and showing that the remainder is not 0. Bring down your 1, multiply, negative 5, add, negative 8, multiply, 40, add, 41, multiply, a negative 205, add, negative 200. Again, 1, negative 1, 5, negative 5. The remainders are not 0. So therefore, none of these are the only rational roots. So if it has one real root, and none of these rational roots work, it must be irrational. So the root must be irrational based on what we just said. Because it's not rational, not 1, negative 1, 5, or negative 5. So it must be irrational. So how do we can't find the irrational root, but it has between 2 and 3. So let's sub in when x is 2. So I'm going to take the equation and put 2 in. I'm going to put 2 in the place of x. When I do, and I put 2 in the place of x, I'm going to get a remainder. Remember now, it's 2 is irrational. So is it a root? So let's check. 8. 4 times negative 3 is 12. Negative. Negative 2 plus 5. So that's 14 and 13. So that's negative 1. And let's check with x equals 3. So I'm going to put a 3 in. Putting 3 in the place of x. 3 cubed is 27, and 3 squared is 9, so that's negative 27, minus 3 plus 5. They cancel out, and I get a 2. So when I put this in, when I put sub 2 in here, I'm getting a remainder of negative 1. I'm getting a remainder of 2. But as I said before, the remainder is your y value. So the y, when x is 2, if you did a graph on this, your y value would have been a negative 1. So your remainder is your y value, and the y value is 2. So when you have a graph and you put x is 2 in, let's say x is 2 right here, that's 2, and this is x is 2, and that's 3. So what happens? At 2, the y value is negative 1, which is right here. At 3, the y value is 2, which is up here. So what happens? If 2 gives me a y value of negative 1, and 3 gives me a y value of 2, that means the graph, it has to have at least one. The graph cuts through like this. So somewhere between 2 and 3, this graph cuts through the x-axis right there. So we don't know what the number is, but it's going to be irrational. It's not rational because it's not 1, negative 1, 5, or negative 5. So it has to be irrational. And again, it's real because an odd degree has at least one real. And it has to be between 2 and 3 because it's positive, y value, negative y values between 2 and 3, it intersects the x-axis. And again, pause the video and work each of these out. Find a remainder when this expression is divided by x minus 1. So if I do synthetic division on this, it wouldn't be good, because I would have to go x to the 0x to the 98, 0x to the 97, all the way down. So let's do a synthetic division with a negative 1. So I won't do synthetic division. I just said I wasn't going to do it, and I did it. So let's dividing by x minus 1. So we're going to do a negative 1. So when I sub a negative 1 into x, I should have a remainder. So subbing negative 1 in, I'm going to get my remainder. It's called the p of negative 1. So the p of negative 1 is my remainder. So work this out. Negative 1 to an odd power is negative 1. Negative 1 to an even power is 1. So negative 3 times 1 is negative 3. Negative 1 to an odd power is negative 1. 7 times negative 1, negative 7. And so I have negative 11 plus 9 is negative 3. So the remainder is negative 9. You would not want to do synthetic division, because you'd have to do x to the 99 plus 0x to the 98, etc., etc., etc. To do the synthetic division, plus 0x to the 97, and keep on going. Too long, so it's best to sub in the negative 1. Okay, number 5. If 2 is a root of this equation, find the other roots. So if I have one root and I sub it in, notice this is 4 degrees, so this has 4 roots. It's in descending order of 4, 3, 2, 1, 0, nothing's missing. So I'm going to do a synthetic division by 2. If I sub 2 in for x, it'll only verify that I'll get a 0 remainder. I won't, but by doing synthetic division, I get a depressed equation. So I got 1, negative 3, 11, negative 27, and 18. Draw a line, bring down your 1, that's a 2. Add negative 1, multiply negative 2, add 9, multiply 18, add negative 9, multiply negative 18, and remainder of 0. So 2 is a root, so we knew, I got a 0, so that's verified. Now I have a depressed equation. So I have, that's an x to the 4th, that's x cubed, x squared, 9x minus 9, that's the constant. But if you notice, these coefficients adds up to, that's negative 10. These two add up to 10. 10 and negative 10 is 0. Because the sum of the coefficients is 0, that means that 1 is going to be a root. So if I do synthetic division by 1, then I'll get another depressed equation. Let's see, bring down the 1, multiply 1, add 0, multiply 0, add 9, multiply 9, add 0. 0 is a root, because the sum of the coefficients is 0, 1 is a root. 0 is a remainder, 1 is a root. So the equation is x squared. So we have one root. Remember, there's 4 roots, so we got 1. We already have 2. And we have x plus x squared plus 0x plus 9. Again, this is x to the 4th. When you divide, you get this is x cubed. When you divide again, this is going to be x squared, because it goes down by 1. That's equal to 0. So x squared plus 9 equals 0. X squared equals negative 9. Square root of x squared is plus minus the square root of negative 9. Square root of x squared is x. Plus minus square root of 9 is 3. And it's a negative, so we have an I. So the other roots, are, we got 1, and we got 3i, and a negative 3i. So there's 4 roots altogether because 2 is given to us. And we have one more to do. Number 6. Negative 1 is the root of this equation. And notice it's cubic, so it has 3 roots. It says find the 2 equations. So to get the 2 equations, you got to say 2 equations. There's only 1 there. Well, let's work it through. Because negative 1 is a root, then let's sub it in and see what happens. So I'm going to sub the negative 1 in. And when I sub the negative 1 in the place of x, take my time, putting a negative 1 in the place of x. So subbing in the negative 1 with the root makes the remainder equal to 0. So I have negative 8, that's negative 1 cubed is negative 1, so that's an 8. Negative 1 squared is 1, so that's negative 6. And that's negative 1 times k is negative k squared plus k equals 0. So I have a 2 minus k squared plus k equals 0. And so I have a negative descending order. Now I got 2 choices. Notice I end up with a quadratic. Quadratic is probably does give me two answers for k. So I can either, I can do 2 things. I can factor out the negative of 2 of these. So I can take the negative out by factoring. Negative divided by negative is positive. Positive divided by negative. So taking the negative 1 out changes all these signs. And that allows me to factor in terms of k. K squared is k and k. Factors of 2 are 2 and 1. Product is negative, 2. 2 and 1. Product is negative, sum is negative, so it must be negative 2 plus 1. Multiply. Negative 2 times 1, negative 2, add negative 1. So we ignore the negative, k minus 2 equals 0, or k plus 1 equals 0. So k is 2, or k is negative 1. Now I could have, if I wanted to, divided, taken this equation here and multiplied by negative 1. Negative 1 times this equation gives me k squared minus k minus 2. Negative 1 times 0 is 0. So I could have worked on this. So this equation right here is the same as this part right here equals 0. We didn't need to work on the negative. So we got 2 values of k. Putting the values of k in. So if I put k is 2 in here, I get negative 8x. So I'm putting in k equals 2 minus 6x squared. K is 2. So the equation becomes, that didn't change, 2 squared is 4, minus 2 equals 0, so that's one equation. Now I'm going to put in k is negative 1. So I'm putting negative 1 in the place of k. K is right here, as you can see. So I'm putting in negative 1. So negative 8x cubed minus 6x squared plus x minus 1 equals 0. So these 2 equations, there are 2 of them, both of these will have negative 1 as a root. And if you want to check that, take negative 1 and go negative 8, negative 6, 4, and 2. Do synthetic division. Bring down negative 8, multiply 8, add 2, multiply negative 2, add 2, multiply negative 2, add 0, 0 remainder. And we check with -1 in this equation, -8, -6, 1, and -1. Bring down your -8, multiply 8, add 2, multiply -2, add -1. -1 times -1 is 1. And again, the remainder. So you can see that there are two equations, because when we solved this, we had a quadratic here. So that means we ended up with having two different equations, and I verified by synthetic division with -1 that these two equations are okay. So again, different equations helps you think. The more problems you do in math, the better hopefully you will understand. You need to practice your skills. And if you like my video, click on the like button. Click on the subscribe button if you're not a subscriber. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. The content is on my YouTube channel called Math Fully Explained. I hope you learned something from my vehicle. I hope you enjoyed, or video I should say. Thank you very much for viewing my video. Bye-bye.